Hello everyone, welcome to this new lecture. So in this video we're going to see about bending and shear forces. So this is our third topic. The first topic was about stresses and strain relationships, and second was about SFT and BMD. Now we have come to this topic. So let's get started.
And before we start, I would really appreciate it if you could smash that like button, drop me a comment and share this free program with anyone who might need it.
So the basics that you should know are two things. So first is our bending equation. M is the moment due to the applied load of the given structure, and I is the moment of inertia. Sigma is the flexural strength, and Y is our centroidal distance. E is our modulus of elasticity, and R is our radius of curvature, and 1 by R is what we call curvature. The second thing to keep in mind is about shear stresses. So we have different types of sections. So we have something called maximum shear stress and average shear stress. There is a relationship between the maximum shear stress and the average shear stress. I am sure you guys know that. If you want to know about it, comment below. I will make a video on it, giving you the answers right away here. So the relationship for square and rectangular elements are tau max is equal to, this is tau max is equal to 1.5 times average. That is tau average. Then coming to circle, it is tau max is equal to 4 by 3 or 1.33 times tau average. And coming to triangles, so triangle is a bit different. So we have like two types of shear stresses in our triangle, and this is our midpoint of the triangle. We have shear stress along the midpoint, which will be our maximum shear stress. In this case, our shear stress will be along the neutral axis. That is, the maximum shear stress will be at the neutral axis. For circle also it's along the neutral axis. For the rhombus also it's along the neutral axis. Whereas for triangle it will not be along the neutral axis. It will be along the midpoint. Along the neutral axis also we have another kind of shear stress called neutral axis shear stress. So giving you a relationship for both of them. Now coming to rhombus. So for rhombus, tau max. So going to the first question, a simply supported beam of span L carries a concentrated load W at the midspan. If the width of the beam is B and it is constant and the depth of the beam is varying throughout the span. So if this is my span, the depth is varying throughout the span. Okay. So what will be my depth at the midspan? So this is a beam, we can use a bending equation. So sigma can be written as M by I into Y. So this can be written as I by Y, right? So I by Y is equal to Z, which is our section modulus. And section modulus for a rectangle is BD square by 6. We can say that sigma is equal to M by Z. So sigma, they have told that it is represented as F. So F is equal to M. What is the M of the given structure? It is subjected to a point load. A simply supported subjected to point load, the maximum moment is WL by 4. WL by 4 divided by our Z we have found out already, BD square by 6. BD square by 6. So from this I need to find what is my D. This is my answer. So option C. Next question. A beam of T section has I is equal to 1200 centimeter per 4 and depth is equal to 12 centimeter. The flange of the section is in compression. If the maximum tensile stress is equal to 2 times compressive stress, then what is the section modulus? So what is the general rule of section modulus? If this is my section, then this is my neutral axis. So this will be my centroidal distance, which is D by 2. If this is D, this will be D by 2. So this is what we will use for finding section modulus. Section modulus is equal to moment of inertia divided by Y, which is equal to BD cube by 12 divided by D by 2, which will only give you BD square by 6, which is what we used in the previous question here. So this is how we will find section modulus. So for rectangular section it is easy, whereas for a T section it is quite different to find the section modulus. That is, it is different to find your Y value. For that only they have given you this condition. So if you had listened to the RCC lectures that I have made, you know that it is using this relation only we will find our neutral axis depth. So they have told that tension is equal to 2 times compression, which means this is my tension zone. The flange is in compression. This is my tension zone and this is my compression zone. So neutral axis lies somewhere here. So they have told that tension is equal to 2 times of compression, which means tension by compression is in the ratio of 2:1. T is to C is equal to 2:1. So if this is tension and compression are divided on the basis of this ratio, then their depth will become T is equal to 2, right? So 2 divided by 3. I am sure you guys know the basics of how to find the ratio. It is 2 divided by 2 plus 1 into 12. So tension will be occupying a length of 8 centimeter. So this is 8 centimeter, which is completely in tension. So the remaining is 4. Total is 12. So the remaining will be 4 centimeter. So 4 centimeter is given to compression. Now coming to our section modulus is equal to I divided by Y. So here what is Y? Y means the distance from the neutral axis to the extreme fiber. Here the distance from the neutral axis to the extreme fiber, it is given as 4 centimeter. So it is equal to 1200 divided by 4, which is equal to 300 centimeter cube, which is your answer. So option A. Next question. The width of the beam of uniform strength having constant depth D and length L simply supported at end. So simply supported end, W is acting, central load. So they have asked what is the width of the beam. So this is similar to the first problem here. So here you can see that 3 by 2 is coming. So I am going to use that here. It is just the same formula. So I am not going to read it again. So only 3 by 2 comes here. So my answer is option B. The same formula in the previous video, the previous question was D was asked to find. Here B is asked to find. That's it. Next question, a beam of rectangular cross section is 100 mm wide and 200 mm deep. Okay. And the section is subjected to shear force. Vu is equal to 20 kilonewton. What is the maximum shear stress? So this is my rectangular section. So my tau max is equal to 1.5 times tau average. So what is my tau average? It is equal to Vu by Pd. Option D. Next question. Ratio of flexural strength of two square beams, one placed with two sides horizontal. So two sides are horizontal. If this is the side of my beam, two sides are horizontal. And other placed with one diagonal vertical and other horizontal. So this is my diagonal. If my diagonal is going to be vertical, then it means that my beam is placed something like this. My diagonal is vertical and another one is horizontal. So if the side of the beam, if it is taken as A, then this is also A. They have asked what is the ratio of flexural strength. So whenever flexural strength is asked, you have to think of section modulus only. The flexural strength of any member, it is determined by the section modulus. So we have to find the section modulus of these both things. For second one, section modulus is equal to, so this is a rhombus. So this is like a rhombus and the side of the rhombus is A. Then what will be this distance? We know that it is equal to A by root 2. This is our centroidal distance. So this will become BD cube by 12. That is, I am going to use the conventional way by I by Y. Y is the same for rhombus. It is also BD cube by 12 divided by Y is equal to A by root 2. So this is my Z1, this is my Z2. So if I find the ratio of them both, it will become this option A. Next question, the modular ratio of the material used in a flitched beam is 10 and the ratio of the allowable stress is also 10. Four different sections of the beam are shown in the given figures. The material hatched has larger modulus of elasticity and allowable stress than the rest. This last line is very, very important. The material hatched has larger modulus of elasticity and allowable stress than rest. This means that this hatched area, it can be converted to the normal area by increasing its area. That is, the equivalent area of the first section will be something like this. If this is my unhatched area, my hatched area can be increased in its size so that it can match this area. So this is how it is told. So second section will be, if this is my unhatched area, my hatched area will increase in section like this so that it will become an I section. All the given sections would support the same magnitude of load. I don't think it is true because they have different section modulus, and sections 2, 3 and 4 would support equal loads, which is more important than what section 1 would support. That is also not correct. and the section 1 and 2 would support equal loads, which is more than section 3 and 4 would support. So 1 and 2 would support equal loads, will they? Because this is an I section, the strongest of all sections. This will not be same as that of this rectangular section. Therefore, C is also not correct. And section 2 would support the greatest load. That is correct because section 2 is an I section. It will provide a greatest load. Next question. So the cross section of two beams A and B are shown in the figure. Both the beams have the same material. By how many times is beam A stronger than that of beam B? So they have asked for strength, which means you have to go for section modulus. So section modulus of two things are going to be compared. So section modulus of the first beam, it is, the answer is option D. Next question, the beam of uniform strength refers to which one of the following? A beam in which extreme fiber stresses are same at all cross sections along the length of the beam. So a beam is something like this, in which extreme fiber stresses are same at throughout the cross section along the length of the beam. That is correct. The answer is option A. Next question, the maximum shear stress in a circular cross section is what? So we have already seen for a circular cross section, tau max is equal to 1.33 times tau average. This is equal to 4 by 3. The answer is option B. With this, we come to the end of this video. In the next lecture, let us look into 10 more questions on this topic. Thank you so much for watching, guys. I'll see you in the next video. Bye.